Before we get into solving the actual factorial problem, first let's review what recursion is quickly, since we will be using it to solve the problem. Recursion is a programming technique used to solve computer problems by creating a function that calls itself until your program reaches the desired result. Recursion consists of two parts. Number 1, the base case. It is the halting case of a function. The base case is what stops a recursion from running forever. Every recursive function must have at least one base case. And in a nutshell, the base case is the solution to our subproblem, or our problem thus far. Number 2, the recursive call. This is a code that calls the function itself. This function will call itself over and over again until it hits the base case. If there is no base case, the call will just keep running forever. Let's take a look at an example. Let's say you're at a grocery store and there are people in line waiting to buy something. Let's say person 1 is at the end of the line and he doesn't know how many people are exactly in line. So what he does is he asks person 2, "Hey, how many people are in line?" Person 2 doesn't know. So person 2 will also ask the person in front of them, "Hey, how many people are in line?" And person 3 doesn't know the answer either. And person 3 will ask person 4, "Hey, how many people are in line?" Person 4 is at the end of the line, and so person 4 tells person 3, "Hey, there's 4 people in line." Because we're at the end of the line. Person 3 then says thank you and turns around and tells person 2, "Hey, there are 4 people in the line." Person 2 then tells person 1, who asked the question in the first place, "Hey, there's 4 people in the line." And because we finally got our answer back to person 1, the person who asked in the first place, we have our solution, which is 4. So there's 4 people in the line. Now in this example, person 4 is our base case because that person knows the solution to what we are looking for. If the line went on forever, then we would be asking how many people are in line forever, meaning our recursive call in this case would never end. Hopefully this gives a good high-level visualization of what is happening under the hood in recursion. Now let's get back to our factorial problem. Your task in this section was to write a function when called like this will return the factorial of 5 or any input in the function. So in this case, we have 5 as the input, so it should return 120 as the answer. As a quick refresher, a factorial of a number is the result of that number multiplied by the number before it and the number before that number until you reach 1. And so for 5, if we wanted to take 5 and get the factorial, we need to multiply 5 by 4, by 3, by 2, and so on all the way until we hit 1, which will give us 120. So let's write it out. First, we need a function called factorial. And it should take in a number argument. And now we need a base case. So what is our base case? Well, we know that if we hit 1 in our list of numbers, we do have to return a product of all the numbers in the list. And so our base case could look something like this. And so what is our recursive case? Well, it should be that we are multiplying the number itself with the number before it. So it could look something like this. And that's it. Let's log it out now to see if this works. Great, we got 120. So why did this work? What is going on under the hood? Let's try to step through the function and follow the logic here. So first, we call factorial with a 5 as an input. So inside this function, we check it against the base case. If num is 1, then return 1. Well, 5 is not 1, so we continue. In this case, we have to return 5 times factorial 5 minus 1. So it would be 5 times factorial 5 minus 1, which is the same thing as 4. Let's keep going. We're calling factorial 4 now, so inside that function, we check it against the base case again. It's 4, 1. Nope. So we keep going. And next, we have to return 4 times factorial 4 minus 1, which is 3. So we do 4 times factorial 3. Go inside the function. Is 3, 1? Nope. So we keep going. And we return 3 times factorial 2. Then we go all the way to 2 times factorial 1. So now num is 1, which means that's our base case, right? So we have to return 1. We found our answer. So here we just return 1. And 2 times 1 is 2, which is the answer to factorial 2. So we return 2 here. 3 times 2 is 6, which is the answer to factorial 3. So factorial 3 is 6. Now 4 times 6 is the answer to factorial 4, which is 24. And now we finally have the answer to factorial 5, which is 5 times 24. And so in the end, 120 is our answer. Notice how our answer keeps bubbling its way up to the top until we finally get our answer. Recursion makes use of something called the call stack to do this. So every time a program calls a function, that function goes on top of a call stack located in virtual memory. Great. I hope you learned a lot about recursion in this lesson. See you in the next video.